Hello and welcome. This session is titled Maps with Power BI the Easy Way. Now let's get the most important things dealt with in this particular session. Let's thank the sponsors. The sponsors make the opportunity for me to even be able to speak to you possible. Without them, this event and this session would not go ahead. So please thank the sponsors. Please take some time just to pop in, even if you just go and say, thank you very much for sponsoring the conference. I'm sure that even that be appreciated. I know certainly when I've attended conferences, I've gone and spoken to vendors, there's things that I have found and have come away with that I have recommended to my clients. So please take some time to do that if you get the opportunity. I'm not going to pretend I'm an expert with maps and mapping technology. I find my way and I can do things. I might be very proficient and really good at SQL Server, maybe Power BI, and maybe some other things. But with the mapping things, I have to say I have a bit to go. So today I'm just going to show you the technologies and the techniques that I use to achieve different things with mapping. And hopefully there's some things today that you might learn. Now, I have a confession to make. I love maps. Maps are incredible, and the more I learn about the maps, the more I'm amazed at just how much information they manage to cram onto a map. And as such, I seem to have just loved them ever since I was a child. Here in the UK, we have the Ordnance Survey, who've surveyed the whole of the UK and published Ordnance Survey maps. And I still remember as a child purchasing Ordnance Survey maps where I lived. I'm just going out and exploring with Ordnance Survey maps, or just poring over them, trying to find out things that I knew that I could relate back to the landscape from the Ordnance Survey maps. Now, I also love Power BI. Yeah, I have worked with Power BI since it came out in Excel 2010, many years ago now. And the first time I used Power BI, and I think it was called Power View at that point, I thought it was just the most amazing thing that I had ever seen. And I've loved Power BI since then. It was love at first sight, and it still continues to be a romance I carry on today. At the time, I was working with SQL Server reporting services, and I loved maps so much that what I created was a map report using SQL Server reporting services, using some of the techniques I'm going to talk about today. And it was drillable, so the managers at the very top could drill into the territory manager, then drill into the individual locations, and then go back up again. That was a challenge. It was a fun challenge, but it was a challenge. The thing about today, and particularly today's budget that I'm looking at, is this is the budget we have, £0 and 0 pence. Okay, we're not going to spend any money. This is typically the budget I'm presented with when I'm looking to do some development, or sometimes I'm working with clients. It does have a downside in that there are some tools we are not going to look at today. ArcGIS and I think Map Toolbox, both are visuals that are available in Power BI, but they cost money, so therefore I'm not going to consider them. Okay, hopefully that's not too much of a downside. All the code, all the files, all the reports, links to the websites, and all the things I mentioned today are at this GitHub repository. Okay, so if you click on that link, it will take you to the GitHub repository where all the files are located. Okay. What are my goals for today? What am I going to try and achieve? Well, I really just want to show you what I work with, what tools I use when I'm working with maps. There's a couple of different tools and a couple of different techniques, and I just want to show them to you. I also want to show you some of the basic building blocks in maps, particularly map reports. They are not that complicated, I'll be honest with you, I think. And very much like Lego, there's so many people I see on Twitter who play with Lego, and I just love it. They take these small individual building blocks and they put one and they put another one on top of it, and then suddenly they create something magical and amazing from these lovely little tiny building blocks. And that's kind of what I feel about maps. They're just simple building blocks. If you put them together, you create something amazing. Now, I've been talking for quite some time now, and you're probably wondering, who on earth is this person speaking to me? Well, let me introduce myself. My name's Robert French. I work for a consultancy in sunny Glasgow called iAcademy. These are the ways you can contact me if you want to. I love maps, I love talking about maps, I love talking about data storytelling. In fact, anything to do really with reporting and other exciting things. That's my Twitter handle. If you want to have a good laugh, please feel free to look at my LinkedIn profile. Quite a few recruiters have in the past, and that's my blog post where I occasionally blog. So, what are we going to talk about today? There's a couple of different topics. First one is, how do you take a sphere, say a football, which is the Earth, and place it onto a flat surface, such as a map? There are some complications there I think we need to be aware of. I just want to point out one particular technical thing. Then we're going to look at the basic building blocks of maps and three different elements. Okay, we're going to talk about those three basic elements today. I want to have a quick look at geographical file types, because we're going to talk about a couple of different ones today. I just want to make sure we've covered off and discussed them. Then we're going to have a talk about the tools that I use. I want to make sure you're aware of the tools and how I actually use them. I'll show you what I do. And then finally, yes, we're going to get to talk about PowerBI. Okay. This is Pat the sheep, who happens to be in a cottage in North Uist, where we go and stay in November. And yes, he does have orange hair, seriously. There is a story to that, but I'm not telling you today. So, first part of our session is about taking a spherical object, such as the Earth, and placing it on a flat surface. So why would you want to do that? Well, one of the reasons is so we can actually tell where we are on the Earth. And it's a little bit complicated, because even though you open up maybe your map function and you're able to tell exactly where you are using your phone, there are some challenges in that, believe it or not. The Earth is round. Yes, I know. And if you think the Earth isn't round, you're in the wrong session. Okay, I'm not even going to argue about it. I think you should stop now and leave. Okay, so the Earth being round or spherical means that it's difficult to put it on a flat surface. Okay, actually you can't. There are some very clever people called cartographers. Okay, and they're involved in creating maps. And in order to be able to do that, what they use is a couple of different techniques, and one of them is something called projection. Okay, these are three different projections I'm showing here. Each projection has a slightly different upside and downside depending on which one you choose. These are the examples of the projections onto the Earth onto a flat surface. And sometimes it means that some of the sizes, some of the countries are not quite representative of how large they are in real life. Now, the other thing you need to be aware of is latitudes and longitudes. Okay, that allows us to be able to pinpoint a place on the Earth. So what's happened is the cartographers have gone to the North Pole and the South Pole and divided the Earth up into different lines, longitudes. There's 360 of them all the way around, and that gives us lines up and down from the North Pole to the South Pole. Okay, then they went to the equator, which is the middle of the Earth, and have mapped latitudes. Now, that means that you can actually physically identify a single point on the Earth. Okay, the term they're using the latitudes and longitudes. For example, if we were meeting physically today, this may be where we are. These are the coordinates. These are latitudes and longitude for the location for Strathclyde University Technology and Innovation Unit. But there's more. Okay, there's one more thing I want to talk about. And you're probably feeling a bit like, well, he spent a lot of time talking about this. Why? What's he going to say? If you only take away one thing from today's session, when you're asked what coordinate reference system you want WGS 84. Okay? Yes, I did make this mistake, and yes, I didn't specify the correct coordinates reference system. It's all to do with the mathematics of where you are on the Earth and the shape of the Earth and also other things. But all the GPS systems all use the same coordinates reference system, WGS 84, and it just so happens that PowerBI visuals also use the coordinate reference system WGS 84. And yes, I did make this mistake when I was working on creating and developing some map reports, because I didn't specify the coordinate reference system WGS 84. Deep breath. I'm not going to mention it except when we're talking about exporting files later on. Okay? Now, we're going to look at basic spatial elements. Okay, these are the basic building blocks of maps. And all good things, we're actually going to show you how to create one yourself. So we're going to show you how you can actually make your own basic spatial elements. So if you've got access to the internet, you'll have access hopefully to Google Maps. Just sign up for an account. You've probably come across it before. It contains all sorts of lovely geographical information, okay, including maps and all sorts of other stuff. But what we're going to do, I happen to live in Glasgow near a place called the Borough Collection, and I'm going to use Google Maps to create the three basic spatial elements. So I'm just going to zoom in just now to the Borough Collection, to the entrance. And what I'm going to do in a moment is I'm going to add a point. Okay, just a simple point that shows the entrance to the Borough Collection. I'm going to add it to a map, so just click there. Left-hand mouse click, and as you can see, just going to click on it. There we go, right now. And I'm going to look at point, and I'm going to misspell the word entrance. There we go. I can't spell. There we go. Well, I'm just going to click OK, and it's saved that and added to the map. You can also see there's a latitude and a longitude there, and that shows a unique point on the Earth. Okay. Now, the next thing we're going to add is a line. Okay, a line is used very often for showing where a road happens to be or a path. In this case, one of the paths outside the Borough Collection. I'm just going to create say a track, maybe where I walked. All it is click on a point and join it with another point with a line. And as we go around this little curve here, as you can see, we're just going to use several points just to recreate that curve. Now, if any of you use Strava or anything else to track your activities, just going to call that line. This is what you're getting back as part of your map. Okay, this shows you where you've actually been. Okay. The third spatial element we're going to use is something called a polygon. Now, a polygon is essentially a line, dots joined by a line, and the first dot and the last dot are the same. They're often used to outline particular features. For example, buildings. In this case here, the Borough Collection. This is the most often used for that. It's also used for other features like lakes and other things. But it's very simple, very easy. Just do the last one, left-hand mouse click, and we've created a polygon, which is an outline of the Borough Collection. Okay, just of the building. Okay, so that's that done. Just close that and save it. Just going to zoom out quickly so you can see what it looks like. We now have a map that I can save, and it is saved to the repository, so you can actually open up this particular map. So what do you get? I'm sure you're asking yourself. Well, you've got a map with the three basic simple building blocks that we use in map files. We've got a point, which is a single location on the Earth. We've got a line, which could be a journey you've taken, say from if you went cycling or running from your house and then back, or where you walked to. And also a polygon, which may represent the outline of your house. So you can actually layer that onto a map. These are the simple building blocks that we use for map files and map reports. That's why I consider it a bit like Lego. You're taking these simple building blocks and you're creating something. Now, the other thing I want to quickly talk about is geographical file types. Okay, just very quickly. There are 4 different ones I'm going to mention today because there's 4 different types we're going to work with as part of this demonstration. The first one is a shapefile. If any of you have ever worked with maps, you've probably come across shapefiles. They often come, it's the oldest geographical file type. It usually comes in a zip file, can contain a minimum of 3 files, sometimes up to 6 or 7. And can have lots of information associated with the elements within that particular file. This is one particular example here from the Office of National Statistics I downloaded. Comes in a zip file, really short, snappy name, as you can see. When you extract the zip file, you can see that there happens to be, 6 files in that zip file. And that is essentially the shape map file, okay, or files. What's the next one we're going to talk about? We're going to talk about geojson. Okay, that's another file type we're going to work with today. Single file, which is great, nice and easy, based on JSON format, and can have the 3 basic spatial elements we've spoken about. That's why I mentioned those earlier. What does it look like? Looks like this. Okay, The other one, the other flavor you can possibly work with is TopoJson. Okay, very similar to GeoJson. Again, based in JSON format, can have the three basic spatial elements we noted earlier. What does it look like? This. Not particularly exciting or interesting, but it's amazing what you can do with these files. The last one I'm going to mention is more a file, a way of representing data, but you can also get WKT files as well. This is well-known well-known text. Okay, it's not in JSON, it's in text. Okay, it isn't supposed to be human readable, but if you look at it, you can probably figure out what on earth it is. So this is what it looks like. Now, let's look at some tools that I work with on a regular basis when I'm working in maps. Working with maps. So there are two tools we're going to use. They are QGIS. Okay, this is a free open source tool that anybody can download and install their PC if you want. As I said, it's free, it costs nothing. There's also this website which I've been recently introduced to, and it is an absolute labor saver. It makes life very much easier for me, I have to say, and I've used it quite a bit recently. So let's look at QGIS. If I was trying to describe QGIS to anybody, I would call it the Swiss Army knife of GIS programs. There is not much that this particular tool cannot do as far as I can see. I have been amazed. When I go and look to see how do you do something, QGIS is usually the way that someone has suggested a way of doing it. It's open source, it's therefore freely downloadable, available for anyone to use. So the first question I'm sure you're asking is, what can it do for me? So I'd like to try and answer that question by talking about an example of some work we did last year for Tyne And Wear Fire and Rescue Service. They were all excited about PowerBI reports and possibilities of what it could do for them. So we wanted to see if we could create a suitable demonstration to try and demonstrate to them what PowerBI was, what things you could do with PowerBI. So the first thing we found out, which I didn't know, I have to say, is every time that a fire and rescue service or vehicle was sent to an incident, that incident is recorded centrally. All that data is collated centrally. So when a fire engine goes out and puts out a fire or responds to an accident or anything like that, the details of where it happened, what happened, when it happened, is all recorded centrally. Okay, and the Home Office make that data available in the form of fire statistics. And there's quite a bit of data, I have to say. So I spent a little bit of time looking at that and looking around, trying to see if I could find something that would hopefully create a suitable data story that we could speak to Tyne And Wear Fire and Rescue Service about. And after a little bit of looking around, we found a particular file that contained a list of all the incidents, and I could filter it down just for Tyne And Wear because it happens, if you look back, this is actually for the whole of England and Wales. Okay, so there's quite a few details in this particular spreadsheet. So I managed to filter it down to Tyne And Wear, and after a bit of looking at it, looking at the data, I noticed that column E, I eventually figured out that was referring to something called a lower super output area. Okay, that's used particularly, I think, by the censuses and also various other governmental bodies. And as far as I understand, technically, a lower super output area is a collection of about 100 postcodes in an area. Okay, it allows them to group an area together. The equivalent in Scotland just happens to be data zones. We'll talk about data zones later on, but they're the equivalent of each other. One is lower super output area and one is data zones in Scotland. They're very similar in purpose and function. And there are other polygons, for example, other areas like Westminster constituency, people that are represented, or possibly council wards. So I managed to find that lower super output areas, I could possibly get some geographical data or polygons for that. So after some Googling and looking around, I ended up at the Office of National Statistics Open Geography portal. If you ever get some time, this is an absolute gold mine for this sort of information. You can get, for example, all sorts of different shapefiles representing council wards, parish councils, Westminster constituencies, all sorts of lovely information. This particular file, this other page is about lower super output areas, which is exactly what I needed because I had data from the fire service saying where the incident had occurred, and I wanted to place it on a map, but I wanted to have essentially an area and see how many incidents had occurred in that area. So this meant I could download a shapefile. That's great. Okay, so I was able to download the shapefile, quite a large one I have to say. However, what I got was lower super output areas for the whole of the UK. Well, actually in this particular case just for England and Wales. But what I wanted was the lower super output areas just for Tyne and Wear. Okay, I don't want every single lower super output area for the whole of England and Wales. I just wanted it for Tyne and Wear because that's all I was focused on at that particular point in time. So I had a bit of think about this, and I knew that I was able to manipulate shapefiles using QGIS. So I thought, I wonder if I can do this. So I installed QGIS, I opened it up, and I said, right, okay, layer, add a vector layer. Okay. So what I did is, the other thing to remember is when you get shapefiles, always unzip them. I made that mistake and bang my head against a brick wall for several hours because the next step we're actually going to edit them. Okay, so always unzip them, otherwise you won't be able to edit your shapefiles. So what you do is the source type is a directory because this is the directory where I actually extracted the shapefile to, lsoe-shp, nice and short. Selected that folder, and once I did that, this is what happens. It opens up QGIS, and suddenly what you've got is obviously all the lower super output areas for England and Wales. Now, you'll notice in the bottom right hand side that the coordinate reference system is wrong. Okay, I wasn't able to fix that using QGIS. I had to use a different tool to do that, but it's just to let you know it's wrong, just to point that out. Okay, because I'm sure somebody will email and say, by the way, that was wrong, did you know that? And yes, I do. So the next step is open up a shapefile. Let's see if we can actually edit it. To be able to edit it, you have to do a right-hand mouse click in the layer menu on the layer. Okay, and then go down to toggle editing, left-hand mouse click to allow editing. Otherwise, it's read-only. Okay, so once I've done that, next thing I want to do is open the attribute table. Okay, so right-hand mouse click on the layer menu, go down to open attribute table, left-hand mouse click, and it opens this up. Now, this might not seem particularly exciting or really sexy, but every single polygon in that file, the LSOA11CD is a unique value associated with that polygon. So every single lower LSOA polygon within that shapefile has a unique number. Now, I knew from the spreadsheet that for Tyne and Wear, I can get a list of all the shapefile codes, sorry, all the LSOA, lower super output area codes, I can get a unique list of them. And I thought, oh, I knew I could do something exciting with this because I knew if I opened up the expression editor, which is just up here, number 3. Okay, open that up. So when it opened up, I knew I could write an expression. So quick bit of Googling, I found the expression I wanted, which was field name. In this case, I'm going to use the reverse here. I'm saying field name LSOA 11CD not in, followed by a list of lower super output area codes for Tyne and Wear. Now, the not in is quite important because what I'm saying is highlight or select all the polygons or low super output areas that are not in Tyne and Wear. Okay, so once you've done that, select the features, click close, and you go back. So every single one that is not, okay, not in Tyne and Wear has been highlighted in red. That then meant I could click up here and delete, click delete, and that would delete all the lower super output area polygons except the ones in Tyne and Wear. So I did that, and this is what I got. Okay, I just zoomed in here just a little bit, and I see it's just the LSOA codes for Tyne and Wear. Ooh, fantastic. So next thing I want to do is obviously rename the layer to something that was a bit better, from the a slightly shorter name from the one that was there to Tyne And Wear, okay? And all I'm going to do now is I'm going to export it. So right hand mouse click on the layer, go to export, save features as. QGIS talks about features, okay? They're polygons or lower super output areas in this case. And I'm going to export it as a shapefile. Notice the CRS is still wrong. I wasn't able to fix this in QGIS, don't worry about it. I'm going to export it as a shapefile, so the ESRI shapefile format. Okay. Once I'm happy with that, I just click on OK, and what happens is it exports it to this particular directory. Again, in the repository, you will find these files. So it's all there, so you can go and explore these to your heart's content. So I now have a shapefile that only contains the lower super output areas for Tyne And Wear. Oh, so this is where Map Shaper came in. Map Shaper is fantastic because I had a bit of a challenge at this point. I had polygons that represented lower super output areas for Tyne And Wear. They were in a shapefile format. However, I knew that PowerBI map visuals, the ones I was going to use and demonstrate, could only use files that were either GeoJson or in TopoJson file format. So what I did is I opened up Map Shaper. Obviously I did Google this, and thank you very much to everyone that's blogged about this. And I selected the shape files that I created earlier, okay, from QGIS, and imported it. So now I've imported the shape files into Map Shaper. Now I'm going to do a couple of things. I'm going to export it, the shape files, to TopoJson. But before I do that, there's a quick thing I'm going to do is that simplify. Okay, there's a good reason for that, and I'll explain it in a second. So to simplify the file, click on simplify, and these are the options that I use. If these are not the right ones, I'm sure some experts out there will tell me whether it's right or wrong. These are ones I happen to use, and click on apply, and I'm going to reduce it down to 2.5%. Okay, there is a reason for that, and I'll show you that in a second, but simplifying does make life a lot easier if you simplify the file. I found that particular thing, particularly working with the SSRS. Now, the other little challenge I had was this particular shapefile, the CRS was wrong. Okay, it's using the CRS that the Ordnance Survey happened to use. Now, there was a lovely gentleman from Microsoft, unfortunately, whose name I don't know, and there's a couple of people blogged about this since then I found out. And if you click on the console, this allows you to change the projection, or the CRS, sorry. It's really simple. Open up console, type in -PROJ space WGS84, press enter, and it changes the CRS for you. Just incredible, absolutely fantastic. So now the CRS has changed to WGS84. All I need to do is export it as TopoJson. As you can see, I can export it as a shapefile, GeoJSON, or all sorts of other things. Okay, in this case here, this example, this little bit, I'm just going to export it as TopoJSON, so I exported that out. Why did I simplify the file, you're asking yourself, because I didn't answer that earlier? Well, I just said 2.5% because it makes the file smaller. Now, non-simplified is 2.3 meg in size, whereas simplified 0.3 meg. It doesn't make a significant difference to the polygon shape, okay, as far as most reports are concerned. If you do require more detail, then don't simplify it or not reduce it as much. I found that 2.5%, even 1.5% is absolutely fine for all the purposes I've had. It does mean though that the file does load so much faster, okay? And that was hard-won experience. That's why I talk about it here. So it's taken me a little while to get there, but let's start looking at using PowerBI to create some simple maps. There's a very simple built-in map visual, which you can certainly use. It's relatively simple, but really simple to use. Just beware the geocoding is provided by Bing. That means it will take certain things like postcodes, for example, postcode text, or even town or city names, and it will actually identify them using the Bing search engine. What does that mean? Well, if I take this list of postcodes I happen to have kicking around, again, that's in the repository, I can import that into PowerBI. And if I take that value, I've popped on the map visual onto the report canvas, and if I drag in postcode, it immediately takes the postcode text value and says, where is the postcode center, and places it on the map. That's it. That's all you need to do. It's as simple as that. There's also another file there where I've included the latitudes and longitudes as well. That can be found using another website, but that I don't have time to go into right now. And it's simple as that. It's very easy to use, and it's great if you've got simple, you want to find a dot, and you can add more information to it, but we're not going to talk about that one. The one I would like to talk about is a shapefile, which is currently in preview as of this recording. So if you haven't enabled this particular preview feature, go to File, Options and Settings, and go to Options, and tick on the box where it says Shape Map Visual. Okay, and just add it to your Power BI report. You probably have to restart Power BI in order to allow it, to have access to it. So once it's there, you'll find all I've done here in this example is I've just added a shape map visual to the report canvas. Okay, and what I'm going to do next is I'm going to this, obviously the Tyne And Wear data imported earlier, LSOA11CD. I'm just going to drag it and drop it into the legend. And when you do that, suddenly you get a map of United States of America, which is not much good for this particular example. So if you go to Format the Visual, okay, and you go to Shape, expand that out, and you click on Add Map, what I'd like to do is actually import the TopoJson file. Okay, so we created that earlier, I showed you how to create that. We exported it from mapshaper.org. Okay, so we open it up, and then boom, there we go, it's done. Just wonderful. A couple of things you probably need to be aware of. As you can see, this particular tooltip is a standard one built in. I didn't do anything. Literally, it's that simple. If you click on the View Map keys, the thing to be aware of, though, that's one of the things to be aware of, is in the TopoJson file, the column LSO11CD must have the same name for the corresponding codes. Okay, so the codes, the lower super output areas must match, otherwise the data cannot be used to layer onto the polygons. Okay, bit of a pain in the bum, but that's just unfortunately what you have to do. So, returning to the data we had from Tyne And Wear, as you can see here, just to reiterate, there is a column going LSAO code 11CD. That's just the field so that obviously it knows that on the map in the TopoJson file I have this object, and the data that's associated with that object, that record, is represented in the data you imported to Power BI. Okay, so that means you can do things like you can do a count of the number of incidents, get more detail, tooltips, and all sorts of other things. Now that was great. Okay, that's fantastic. The only thing is, the only downside of this particular visual is there's no map layer behind it. I can't add a road map. I can't add a contour map or anything. It's great. It's just all you have is the shape files. That's it. Fair enough. Okay. Now, I did, however, when I was Googling, I found icon map. Okay, and this is a custom visual. Unfortunately, the version I used is not available in the App Store at the moment. I had to go to iconmap.com, which the website's there, and download the beta version. Okay, and all I'm going to do here is import the Power BI visual from a file. Okay, that's all I'm doing here. Iconmap.biz. Click on Open, and I've imported it into my file. Again, everything that you're seeing here, all these Power BI reports, everything is in the repository. Now, so I added to the report canvas. Okay, now, thing about icon map is it works with geojson files and WKT data. Yeah, there is a reason why I talked about these file formats earlier. Okay, what I've done is imported, so the data for Tyne And Wear is already there, and all you need to do is drag the LSOA11CD to the category and to the size. Okay, that's it. Nothing exciting happens though, because there's a couple of steps you need to take. The thing I need to do though was add the geojson file, okay, to a location on the internet where it was accessible. Okay, just these, in this case I wanted somewhere public, in this case I'm using GitHub. This could be a private repository as long as it's accessible by the Power BI report. Okay, that's the only thing you need to remember. In this case it's nice and public. So once I upload it to GitHub, I had to do a couple of extra steps though. So I had to click on the file, okay, and when it opened up the file, I had to go to raw. And once it opened up raw, I then had to grab the URL that popped up. Okay, so I took that URL, went back to Power BI, went back to Format Visual, and see we see geojson URL. After switching on geojson, what I did is I pasted, see that URL, I pasted it into there, and watch what happens. I didn't do anything else. I have to say, when this did this the first time, I was like bowled over. I thought this is just wonderful. It's great because all I've done is I've taken the LSOA 11, dragged it down to count. I popped the LSOA description into category, and then I suddenly get this tooltip popping up. I'm like, wow, this is just wonderful. I haven't had to do anything. Now, obviously, that may not sound particularly exciting because obviously it's a bit dull and boring. So we actually did some work for looking at potholes in Glasgow. So we pulled everything together in Power BI, and I just want to show you what you can do with Icon Map. So this is a little demonstration for something we're doing to Glasgow City Council. This is Icon Map, and all I've done is I've coloured some of the polygons to be different colours. So if there's more potholes being reported, that happens to be in red. Some of the lower ones are in blue, and the ones that are green means there's no reported incidents in that area. There's a little tooltip being added with a map popping out so people can see with the red icons say where the potholes occurred, the blue ones where any pavement incidents, and some other details on the right hand side. And it looks pretty good. It's quite nice if you move over each polygon, it changes the tooltip, which refers to the data zones. Data zones are the equivalent of LSO, lower super output areas in Glasgow, okay, which is quite exciting. It looked pretty good. My colleagues were pretty impressed. Now, I was saying, well, you know, yeah, that's not bad. That's pretty good because, yeah, you have the map and you have the tooltip. That was good in a way, but I was a bit disappointed because what I really, really wanted was the ability to zoom into the polygons or the map. And when you zoom in, I wanted to overlay both the polygon and the individual points because if you're looking on a laptop or a computer, you cannot zoom into the tooltip. You can do it if you happen to work on a tablet, but that's not what we wanted for our audience. We wanted to be able to have the polygons and the individual points on the same map. So when you zoomed in, you could see both the polygon and see where the individual potholes have been reported because we had lat and longs for them. So when I was at Power BI, I was really excited because James Dales was there. This is a gentleman who created Icon Map. He's just incredible, amazing, amazing bit of work. And I said to him, listen, I think it's awesome what you've did. This is just brilliantly fantastic, but I want to have the polygons and the individual points on it. Is that possible? And he says, yeah, just use WKT. And I went, what's that? So a quick bit of Googling, I found out what WKT was, which is well-known text, okay? And it's a particular format for representing geographical data. So what I had to do next is open up QGIS. Surprise, surprise. So I opened up QGIS, I added a layer, okay, I added a vector layer. In this case here, I'm going to demonstrate the idea with Tyne And Wear TopoJson file. So I imported it into QGIS, opened up the file, okay, and added it. So there we go. They've now got the TopoJson file with all the polygons for lower super output areas for Tyne And Wear with the appropriate CRS. And then I went back to the layer, right-hand mouse click and go to Export. And when I went to Save Features As, I'd done a bit of Googling. And what it said was, save the file as a CSV file. Fair enough. This is the location I'm going to save, and as you know, CS is correct. However, it said what you do is you go down to the geometry and you change it to as WKT. I was like, yeah, whatever, see what happens. So I popped it out, and this is what was returned. Wow. What you have in column A, as you can see, you just actually see it up in the top here, is a polygon in WKT format exported to the CSV. Interesting. Now, let's think about Glasgow. In Glasgow, we had exactly the same issue. We had the polygons that we could save as TopoJson. So I exported the TopoJson file with all the data zones as polygons into a CSV file. Magic. So we now had the data zones, which are polygons, in a CSV file. We also had another CSV file which contained the lats and longs of all the potholes that have been reported in the pavement and footpath incidents. So a quick bit of formatting, because the way that WKT represents the point is the wrong way around. Normally it's latitude and longitude. It's actually the other way around. It's longitude, then latitude with a space in between. So a quick bit of fiddling in Excel, because this is a proof of concept. We created the format you can see there in line in row 884. Now what we did, we also added, for example, the data zone code, the name. The data zone was repeated, that's probably not a good idea, and we added the color and also the type. There was a reason for that, which I won't go into in detail. You actually hopefully see that in a second. So I've got 3 minutes left. We then imported that into Power BI. Okay, so Power BI, we dragged the data zone up to the category, WKT value to the where it says icon URL, and also the count of the identifier. So when you pull that all together, what do you get? Well, this is the report. So as you can see before, this is the one we had with the polygons and a tooltip, which I wanted to improve on, and I added this button. And I could add and say, only show me pothole incidents. The blue line shows the data zones, and in the pavement instance, I'll show both. We could also just show the top ranking, or in this case here, anything between 11 and 20. You could also zoom into an individual data zone. You could see the line that shows the polygon where it is for that data zone, but you also had the little individual points with a tooltip, or if you popped out, you could actually see it reverted back to showing the details for that particular data zone on the same map. I don't know about you, but I was completely blown away. It was just perfect. It's exactly what I wanted. Now, there's more work that needs to be done in this, but what I now had was 2 layers. That layer, I had the polygons for the data zones that I could see as blue. That probably needs to be changed the color for color blindness. But I also had the individual points as well on the same map, so I could zoom in and zoom out. I could also filter as well, so I could just show the potholes and nothing else. I could just show the pavement incidents. And if I wanted to filter and just show maybe the top 10 data zones or the top 20, I could do that. I thought that was just fantastic, and I'm delighted that I can do that using Icon Map. It took a bit of work and a couple of fiddling with the tools, but all the files, all the details, all the links, and everything you ever wanted to know is included at this GitHub repository. Now I'm just about to run out of time. It's been an absolute delight to show you this to you. Hopefully it's answered some of your questions. I would love to hear your questions, so maybe I haven't made things really super clear. Please ask me questions. I love talking about this. It's great fun. It's been an absolute pleasure and delight to speak to you. I'm going to stop now, and after the session, after this recording is done, you can ask me more questions. But thank you very much for watching. If anybody else is watching this YouTube or elsewhere, my contact details are at the start. Please feel free to contact me, and enjoy your adventure playing with Power BI and maps. It is so much fun. And I look forward to hearing about what you've created and your adventure.